the question is whether history is plausible or whether the history is real is a very subtle question, and that can be seen by thinking about this situation I described of putting the Earth inside a mirror box. So nothing gets in and nothing gets out. And the atoms and the photons of radiation that are inside there, they just swap around and do everything they could possibly do. And eventually, after a very, very long time, an exponentially long time in the number of atoms in the Earth, which is a really long time, they would run out of things they hadn't done already, so they'd start having to do some of the things they did already before. This is part of the same argument that says that if you have a room full of air, there's a certain chance that all the molecules will go over to one side. So if you had the Earth inside a box like that, there's a certain chance that after everything had gone to the dead state of heat death at maximal entropy, eventually there'll be little accidental statistical fluctuations. There could be a part that gets a little warmer, or some air that goes more of it to the northern hemisphere than the southern hemisphere. And eventually, if you wait long enough, there'll be a fluctuation that produces a thriving Earth like we have today that is not suffering any ill effects from being inside the box. In fact, its whole history of having been stagnant and dead for eons inside the box will have been accidentally erased because it's gone into another form that seems to have a history that has to do with going around the sun and having the moon there. I guess I got rid of the moon. So its history will be, its plausible history will be different from its actual history. Its actual history is that it accidentally reordered itself out of a complete mess in a very short time rather than having evolved over a long time. Let's think about these accidents. They'll keep happening if we leave the world in there for a really immense long time. But let's consider a smaller accident. Perhaps not the whole world reorders itself into the way it is now, but just a cubic meter of it, including your head, reorders itself. This was an idea that was invented by Ludwig Boltzmann in the early 20th century, when he was trying to explain why the Earth is, or the world that we see, is in a state of surprisingly high order, why it isn't already in the maximum entropy state. So his idea was that maybe the universe, of course at that time they didn't know about the expanding universe. He imagined the universe was infinite and static. But he said maybe it really is at thermodynamic equilibrium in this maximally or disorderly state, but it's infinite. And here and there are parts of it that accidentally have become more ordered. In fact, accidentally have become so ordered that they give the Earth the form that we now see. And the reason that we don't see the disorderly parts is that nobody can live in the disorderly parts. So we have a special viewpoint based on having to have a certain organized structure in order to even ask these questions. This is called the anthropic principle, and he didn't call it that, but he was really the first person to use it to say that part of the environment in which science must function is to say we must find ourselves, our explanations must place us into a situation where what we see is typical of what the theory predicts an observer would see if the observer had to live in a part of the universe that could have observers in it. So it's a pretty circular idea. But the idea then, it's a very subversive idea, because instead of having an accidental fluctuation that produced the whole Earth in its current state, why not have a smaller fluctuation, and therefore more likely one, that produced just your brain in its current state. In other words, your brain with memories of things that didn't happen and with all sorts of knowledge about a body of science that was based on observations that never happened. So the plausible history of what's in your brain could be that there was a much larger Earth and lots of experiments and studies and geological expeditions that give rise to a coherent picture of its origin over periods of billions of years, and that all that stuff is fake, and that all that's really there is a cubic meter of matter, which has only existed for a few seconds, and a few seconds from now will be destroyed because it's not in a habitable environment. So that's the idea of the Boltzmann brain, and of course most scientists they certainly reject it, but the problem is trying to find out reasons for rejecting it. We know that if the Earth were at thermal equilibrium, in this heat-death state, it wouldn't be dead forever. It would accidentally come alive briefly, like Brigadoon, but much less often. And all of the experiences in this time that it became alive would be hallucinations. They wouldn't be real. Or occasionally, very, very occasionally, it would actually fluctuate into this situation which was real, but the real things, the ones in which the structure would be as we believe it is, including not just your head, but my head and everybody else's head in town and the whole world and the galaxy and the other galaxies, that would be much less common than these hallucinatory worlds. So this is I would say it's an unsolved problem in cosmology, because any kind of cosmology that predicts that the universe will come to a terminal state that's has maximal entropy and has some temperature greater than absolute zero, which is actually the most common cosmological model that we have now, gives rise to this prediction that in this long dead future of the universe, situations that would appear to us exactly as what we believe will occur many times, and yet the situation that we really think we're in, which is that we're in that we're real inhabitants of a live young universe, that only happens once. But the situation that we are illusions that happen in an old dead universe happen infinitely often. So that's a paradox in cosmology that I only recently became aware of, because I've been doing other things than cosmology until recently, and in the last couple of years I've been trying to learn about cosmology, and this is one of the problems: how to get rid of the Boltzmann. It's called the Boltzmann brain problem in cosmology.